audible in the class? मेरी आवाज आ रही है क्लास में? Hello. Okay, actually अब वो respond नहीं कर रहा. हाँ, maybe देखता हूँ. Okay, I suppose Abu, you are facing some network issues. See, so we did completed this chapter, motion and measurement of distance. So we'll be discussing some question from this chapter. Okay, now, and once we are finished doing these questions, then we will be proceeding with new we will be proceeding further. All right now. So if I'm audible to you, please confirm that. Yes, Abu, please confirm whether I'm audible to you or not. How are we supposed to move further then if I'm not audible to you? सौरभ जी, अगर आप अबू को कॉल कर सकते हैं तो प्लीज एक बार कॉल कर दीजिए, क्योंकि वो बिल्कुल रिस्पॉन्ड नहीं कर रहे क्लास में, क्योंकि नेटवर्क इशू ज्यादा ही हो रहा है.
Yes, sir.
Okay, Abu. Like, why were you not answering? I mean, are you having some network issues in the class, Abu?
No, sir. It was saying that the host is not allowing participants to unmute themselves.
Okay, okay. Was that the problem?
Yes, sir.
Okay, okay, okay.
So I
Anyways.
contacted the people
Hmm.
who are sending the link. Then, like they said to try now. Now it
Okay,
is
okay, okay, okay. Good. So let's basically do some questions and then we will proceed further with the next chapter. Okay, now. So some questions, I will not be discussing some questions which are not part of your exam. Okay, now. So I have actually omitted some of those questions. Like motion, measurement part has been removed. Right now. Okay. So starting from here, what is motion? What do you mean by motion? Yes, Abu, what do you understand by the term motion?
Sir.
Hmm.
Motion. Motion is like motion is um, like it is it is like a change a change in place for a thing or a person.
Okay. For a person, for a thing. Okay. Do we not consider time in it also? हम टाइम की भी बात करते हैं ना, राइट?
Yes, sir.
Okay. So if I were to say you, what is the difference between a body being in a state of rest and the body being in a state of motion? How do you distinguish between that? How do you differentiate that a body is in a state of rest or a body is moving? How do we differentiate that? क्या basis है?
If the body is in rest,
Hmm.
it will stop, and then when it is in motion, it will be moving.
The most important thing you should be adding in the definition with respect to time. If the body is changing its position with respect to time, then it is said to be in motion. Okay, now that is the complete definition. So a body is said to be in motion when it changes its position with respect to time. Okay, now Abu. Hmm. In higher classes, we add one more thing. हम एक reference point की भी बात करते हैं. So just like there is a pole here, एक pole है, and a car is passing by. A car is passing by this pole, and let's say it has passed from here to here. So two things has to be noted down here. First thing is that it must have taken some time in order to move from position A to position B. Getting it now? Whenever position is changing, time is also increasing now. So let's say it took 5 minutes to travel a distance from A to B. Further, you have to see okay, with respect to this pole also, the position has changed here. But let's keep it simple. You will simply answer a body is said to be in a state of motion if it changes its position with respect to time. All right, number. So do actually remember this motion. There is nothing too technical about it. Okay, repeat the definition. What is the definition for motion? What did we just discussed about motion? See over here. Change in position of an object with time is known as motion. As simple as that. All right, now getting it now. Question number 13. What are different types of motion? What are the different types of motion we have studied? Yes, Abu. Hello.
Sir, there is
Hmm.
translatory motion,
Translatory motion. Okay.
rotatory motion,
Rotatory motion. Good.
oscillatory motion,
Oscillatory. Very good.
uniform and non-uniform motion,
Very good. Uniform and
motion,
non-uniform motion. Then
periodic motion,
periodic motion. Very good. Periodic motion. There's one
circular,
more.
linear.
Circular.
Sir, this
Circular. And there is
linear, linear
l-
motion.
linear or rectilinear. Both are same thing. Okay, na. Whether you say linear or rectilinear, both are actually same thing. Okay, na.
Sir, linear motion.
Rectilinear motion. Good. And under the translational motion we studied, there are two types of motion. In translational motion, you had the example of two
Cir-
type of motions. Mhm.
circular motion and linear motion.
Circular motion and linear motion. Very good. So these are the following type of motions. Very good. Question number 16. Answer this one. When an object moves in a circular path, such motion is called as what? It's simple, very simple. Abu, if you don't know the answer, just say it to me. Like, sir, I don't know.
Sir, it is circular motion.
Circular
Right.
motion, obviously. You were saying something. Give one example of periodic motion. First of all, like periodic motion is what? When we studied about periodic motion, what did we study?
Sir, it is um, the Earth rotating around the sun.
Very good. Revoluting around the sun, doing revolution around the sun. Earth rotates on its own axis. So rotation of Earth and then revolution of Earth. Very good. Apart from this, we can take example of like mm, you can take example of day and night phenomena also. That will be in rotation. And then you can take example of clock also. Clock also does a periodic type of motion. So periodic motion, what is the main thing we studied about periodic motion? That when a particular type of motion will be repeating itself in equal intervals of time, right? Just like when you study about pendulum, or for example, when you study about rotation, Earth completes one rotation in 24 hours, right now. And again, after 24 hours, it will be doing the same kind of movement. So the type of motion is getting repeated in equal time interval. Okay, then. Next question. Question number 21.
मैं क्लास जा रही छो
Question number 22, 23, 24, and then 25. 5 questions.
Sir, the 20 question is
Give an example of circular motion.
it is like the car going on the make the car making a turn.
No, that will not be a, just making a turn will not be a circular motion. If the body does a full 360-degree motion like this,
Car on
okay,
the
now,
race
then
car.
you can take example of that. Or if you were to simply tie a piece of stone in a thread and then roll it like this, so that could also be an example. All right, now. Hmm. What are other examples do we have of circular motion? From daily life, what other examples we can quote? Yes, like you might have seen, uh, you did told me about the Ferris wheel. Huh? So that is also an example of the circular motion. Or we have example of satellites that are orbiting around the Earth. Getting it, Abu? So they are satellites that are orbiting around the Earth. So they are also doing a circular motion. So in circular motion, we understood that when a body, see, when a body revolves around a fixed point, so thereby it is doing a circular motion. That fixed point is the center here. Try to understand this thing. Like when you hold a piece of stone tied to a thread, and you are holding this in your hand. So around your hand, it starts to rotate now. It starts to move around your hand. So the center point is your hand. So when you are rotating it, when you are basically rotating it like this, so thereby at every given period of time, it is at a fixed distance from your hand. Does the length of the thread changes? No. So similar to that, we have examples of satellites also. Certain satellites which are placed into the orbit of the Earth, and they are at a equal distance from Earth. So those are also doing circular motion. Getting it now? You could have taken example of moon also. Moon is also doing rotation, a movement, revolving around the Earth. Moon is orbiting around the Earth. Or for example, Earth that is doing revolution around the Sun. These are all examples of circular motion. Hope you are able to understand this thing. Okay, no? We have some other common examples also. Like look at the motion of hands of clocks. Motion of hands of the clocks in a watch. They are also doing a circular motion around the center point. They are also doing a circular motion. Getting it now? These are some examples. Question number 22. Strings of guitar being played are in which motion? Hmm. Like, did you remember, like in the example of the pendulum is doing a back and forth motion, to and fro motion. Meaning, see this pendulum moves forward and then backward and then forward and then backward like this. Right now. So that is called as an oscillatory motion. So when the body is moving forward and backward, that is called as an oscillatory motion. So similarly, when you strike the strings of the guitar, that is also vibrating. So that is also doing a oscillatory motion. Getting it above. Hmm. So how do we basically define oscillatory motion? Define oscillatory motion. Oscillatory motion is defined as the to and fro motion of the object. So for example, you had this pendulum. See, you have a pendulum here. This is at rest, let's suppose. So that is called as its mean position. Yes, ये mean position है. Now someone were to push it. So let's say this moves forward. So there it goes. So it moves this much in this direction. So that is called as its extreme position. इसे हम extreme position कहते हैं. And then it later on comes to another position, another extreme position. So that is another extreme position. So you get to see that this pendulum or this structure that you see over here now, this is called as bob. This is the thread over here. Okay, now, am I audible or not? Hmm. So this will be moving forward, and then from its mean position, it goes to the extreme position, right? And then it goes to another extreme position, this one, and then later on returns to its mean position, that is the rest position. So this is how it is doing movement. So we see that it is doing a to and fro motion, to and fro motion, or we also call it as back and forth motion. Back and forth motion. Forth means forward. All right, now. So that is the type of motion. So when a body is doing a to and fro motion, or basically back and forth motion, moving forward and then backward, so that is an example of a oscillatory motion. Getting it now, Abu? Hmm. What are some other examples of oscillatory motions apart from the strings of guitar? Can you think of some other examples? Hello? Yes, Abu, think of some other examples. of oscillatory motion. Like remember the tuning fork I did told you about a tuning fork? Yeah. So tuning fork is also an example of oscillatory motion. If you were to strike one of the ends here, so that will also start to vibrate. Okay, now. So in question number 23, do tell me what is the correct answer for question number 23. Yeah, Abu, you are taking longer than usual. You're taking too much time to answer.
Sir, I don't know.
No, like periodic motion, what we have studied about periodic motion. If you remember, I did give you the definition of periodic motion, in which a particular motion will be repeating itself. See, like the revolution of the earth, rotation of the earth. Uh, so all of them are happening in a fixed period of time, right? Now, like when there's a new year, why when we celebrate new year, when new year is being celebrated, so earth has completed one revolution around the sun, right? Now, so in one year it is doing revolution around the sun, right? Then the next new year it will again be doing a revolution, then again comes the new year, then again it will start the revolution around the sun. So particular motion is repeating after every 1 year. Getting it now, Boo? So thereby we call it as a periodic motion. So object repeats its motion. Obviously that is true. Are you getting it or not? Please do let me know.
Sir,
Mhm. Okay. Question number 24. Hands of clock are example of what type of motion? Okay, let me give you some options. Is it doing a oscillatory motion? Is it doing a circular motion? Out of the two, you can answer. Hands of clock are example of what type of motion? You see this clock over here,
periodic motion.
it will be doing a periodic motion. Very good. Apart from periodic motion, it is actually doing a circular motion also, right now. So if I were to write periodic motion here, so thereby it is actually now doing circular motion also and doing periodic motion also, right? Because the hands of the clock are rotating around a center point, the center point. Okay. Question number 28. If a child is moving on swing, its motion is? Yes, Abu. If a child is moving on a swing, what type of motion he is doing? How does a swing move? Forward, backward, forward, backward, like this, right now. So when a body is moving forward and backward, so
Sir,
where
I
did
think
we study this thing? Mhm.
sir oscillatory.
Oscillatory motion, very good. So that is an oscillatory motion. Question number 30. A ball is rolling on the ground, rotating as well as moving forward on the ground. Therefore, it goes under what? A ball is rolling on the ground. Okay, now, and it is moving forward also.
Sir,
Tell me.
linear motion, circular motion.
Circular motion, more appropriate answer would be it is going under circular motion. Okay, now. More appropriate answer would be it is going on a rotational motion. Okay, now, rotatory motion, and thereby doing a linear motion also. Since it is rotating now, since it is rotating, so thereby it is doing a rotatory motion. So rotational and linear motion. Okay, question number 31. If a person is walking along a straight road, the motion is
Linear.
linear motion. Okay. Motion of falling stone.
Linear.
Linear motion. What is the another name of linear motion? Sometimes it is also called as
Motion.
rectilinear. Rectilinear motion. This question. What is rectilinear motion? Give an example. We just studied this one, right? Okay. Question number 5. What is the difference between motion of a ceiling fan and that motion of a pendulum? Yes, Abu. What is the motion? Difference of the motion between a ceiling fan and that of a pendulum?
Sir, the motion of ceiling fan is rotatory motion, and the motion of a pendulum is oscillatory motion.
Very good. So this one is doing an oscillatory motion. Okay. And when you look at the ceiling fan, it is doing a rotatory motion around this axle. That is correct. One more thing we can see that the blades are doing a circular motion as well. Right now. Good then. Okay, question number 6 and 8, we have already discussed that question. Question number 11, look at this question. What is the difference between motion of a falling stone and motion of a stone tied to a thread and whirled with hand? Yes, Apu.
Sir, there is no difference.
There is a difference here. A stone is falling down. A stone is falling down. So this is doing a linear motion. And in the another case, you have tied a stone with a thread and you are rotating it now. You have tied a stone with a thread and thereby you are rotating it like this. So there's a difference of motion between the two, obviously. This is doing a circular motion and this is doing a linear motion. So obviously there's a difference between the two. Okay, I hope you're able to get it. Okay, these questions now we have already discussed, right? Okay, so that's it. Okay, there's one more question I would like to ask from you. This is not from this chapter, but from another chapter, getting to know plants. Okay, now do tell me one thing. Like, if I were now to draw a flower, let's say this is a flower which I'm drawing over here. Hmm. You have to answer me. What is this? What is this? Okay, now what do we call this? What do we call this? And what do we call the structure inside this?
Sir, that is petals, and that is
The first one is, which
sir
one you are
the
answering, petal?
sir the first one is uh,
Take
uh,
your time, no issues. Take your time.
sir, the first one is anther.
First one is anther. Very good.
The second one is no, filament.
It's filament. Very good.
Sir,
This one is
the
second
third one,
actually.
yeah, the that is petal.
That's petal. Good. Also, do tell me what is this one?
Sir, that is uh, that is style, and the
Style. Good.
upper one is the stigma.
Very good. That is a
Sir,
stigma.
fourth and fifth one is the same thing.
No, actually, fourth. Now I'm denoting to this one, and then the fifth one is referring to the inside of this structure. Okay, now what is inside this structure?
Sir,
One more
there's
thing
only
you can answer. Hmm. See, when
sir,
you were, uh
there's only ovary.
no, inside the ovary, there's one more thing. This one you are answering, that is 1 minute. That is ovary, that is correct.
The,
But inside the ovary, there's one more structure.
the sepal.
No, sepal is this greenish, green leaf-like structure. That is sepal, correct? But inside the ovary, you have one more structure that is called as ovule. Okay, now. So when a flower fertilizes, after fertilization, it starts to convert into fruit after some time. So, for example, take example of a mango fruit. So inside the mango, you will be having a seed. So actually, this seed earlier was ovule, right now. So inside the ovary, you have a structure called as ovule that later on becomes the seed. And later on becomes the seed. And look at this fleshy part, this edible part, that is actually ovary. So ovary becomes the edible fleshy part of the fruit, and the ovule actually becomes the seed. All right, now, Boo. One more thing, do tell me, what do we know? What do we call anther and filament together? And what do you call style, stigma, and then ovary together? Like a flower has got two parts. One is the male part, one is the female part. All right, now. So which one is the male part of the flower? Which one is the female part of the flower? Hmm.
The um uh, sir, the
Is it
stamen.
A? Is it B?
Sir, the
Mhm.
stamen is uh, is the male part of the flower, and then the pistil is the female part of the flower.
Very good. So anther and filament together, we are calling them as stamen. And style, stigma, and then ovary, these three are together called as pistil. In some book, you will see it is also written as carpel. So don't get confused. Both are being referred to the same thing. Okay, now. Okay. Also, which other chapters are coming in your exam? Okay, I think you haven't got the syllabus of the exam, huh? Yes, Abu. Okay. Do one thing. Define what you understand by light. Hmm. We did complete this chapter, light, shadows, and reflection. Can you tell me, like, will light be traveling in a straight line or will it be traveling in a zigzag line? How does the light travel? Yes, Abu. How does light propagates? How does it travel? I guess I'm audible to you. Yes, Abu, am I not audible to you? Please do let me know. I'm audible now. Huh? So answer this question to me. How does light travel? Does it travel in a straight line?
Yes, sir.
Huh. So okay, how do we prove that? Basically, when you will be taking different papers and in each of them you are making holes at equal length, right? Now let's say कि सभी में equal length पे हमने holes की हैं. So thereby you will be able to see the light. But what if you were to make a little bit change here and let's say that you are making a hole over here. Now will I be able to see the light? Will I be able to see the light? Obviously, yes or no?
Yes.
Look at the position of the hole made in this paper. Look at the position. It is here, and it is here. How will you be able to see the light in this setup? See, when you will be looking at the light on the another end, you won't be getting the light here. Why is it so? Because we know that light actually travels in a straight line. So it will travel here, it will travel here, but it will be blocked here. It will be blocked here. Right now. So thereby the person will be seeing no light. So first property in the chapter, when we were doing this, we studied that light travels in a straight line. Okay, now. Hmm. By the way, is light a form of energy? Is light a form of energy?
Yes, sir.
Hello. Hmm. Also, on the basis of how much amount of light can pass from a given object, what are the three types of objects we have studied about? On the basis of how much of light can pass through a given object, what are the three types of objects we have? Hello. Do tell me, like if from a given object, all the light rays passes, almost 99% of light rays, let's say, passes. What do you call such type of object? Okay, let me give you options. Will you be calling it as translucent? Will you be calling this as a transparent? Or will you call this as a opaque object? What do you call such object? Yes, Abu, answer this. Hello. Abu, am I not audible in the class? I
Yes, yes,
suppose I am. Okay, no. Just answer the simple question to me. Or like if you're having difficulty, just do let me know, okay, sir, I'm not able to recall. Hmm. I have given you the options. Will the object be a translucent object? Will it be a transparent or will it be a opaque object? If all the light rays passes through it. Do you recall this when we were doing this chapter? We studied about three types of objects. Huh? If all the light rays passes through the object, so thereby it is called as a transparent object now. Huh? So that is a transparent object here. Huh? Okay, now since I have answered about transparent, can you tell me what did you studied about translucent objects? Hmm. What are translucent objects?
sir, see through.
Yes. Actually, do tell me like tissue papers. Can you pass all the light from a tissue paper? If you were to hold a tissue paper in your hand uh, and try to pass some light from it, will all the light pass through it? Obviously no, right now. Or for example, you have a paper and you try to torch a light from the paper, only some amount of light will be passing through it. So these are some translucent objects now. So translucent objects are those objects which allows only partial amount of light to pass through it. For example, you have butter paper that allows only partial amount of light to pass through it. And then you have opaque objects, those objects which will not allow light to pass through them, those are called as the opaque object. Okay, by the way, can you explain to me how shadows are formed and what are the necessary requirements for the formation of a shadow? How shadows are formed? Suppose you have a torch in your hand and let's say you want to obtain shadow. So the light will be coming from the torch, and what type of object should you be placing in front of the torch so that you get a shadow? Will you be placing opaque object or will you be placing a translucent object in order to get a proper shadow or will you be placing a transparent object? Answer this to me. Yes, Abu. First of all, do one thing. Okay, please show me the notes of this chapter. I suppose you might have made notes of the chapter. Show it in the camera. In the camera, you can show it to me.
Sir, I'm out.
Yes.
Sir, I'm not in my home.
Okay. So do answer this to me. What are the necessary requirements for the shadow formation? First of all, you need a source of light. हमें एक source चाहिए light का. Second of all, you would need opaque object, right? No. So shadow is formed when basically a shadow will be formed when an opaque object comes in the pathway of light, right now. So first, also shadow will be formed on a screen now. एक shadow screen के ऊपर form होगा. Let's say कि you have placed an apple over here. Apple being an opaque object. So you will get to see that a shadow of apple will be formed here. Right now, a shadow will be formed over here. And shadow will be formed over some surface now. So thereby you need a screen. So three things are needed over here. First of all, you need a source of light. Second, you need an opaque object. And the third, you will be needing a screen on which the shadow will be formed. Source of light. By the way, on the basis of source of light also you have two types of objects. Those are namely what? Luminous and the non-luminous object. Can you give example of some luminous objects to me? Yes, Abu, please answer the given question. What are some examples of luminous objects? Or first, just define to me what you mean by luminous objects. Okay, do tell me. Sun a luminous object? Sun emits its own light. So thereby sun we call it as a luminous object. Huh? Sun is emitting light. Other stars are also emitting light. So those are called as luminous objects now. But there are certain objects which are not producing their own light, right? Now, but they are not emitting their own light, and they are visible because light is falling upon them. For example, uh, take this bottle. Uh, is this bottle emitting any light? You might see reflection on the bottle, but is the bottle producing its own light? Anything that is reflecting here on earth, it's not like producing its own light. It's not necessary that it will be producing its own light. It is visible or it will be reflecting light because a luminous object is emitting light that is falling over on a non-luminous object. Simple classification is that you have an object which emits their own light. Those are called as luminous objects. And those objects that does not produces their own light, but they are reflecting the light that is emitted by the luminous objects. So those are known as non-luminous objects. We have so many examples like Earth itself is an example. We humans, trees, different things. Okay, now I think you can answer this to me as well. Like, can you explain to me the functioning of the pinhole camera? How a pinhole camera basically functions? How image is basically formed by pinhole camera? Abu, please respond actively in the class. Otherwise, the class does not look very interactive, and like I also sometimes uh, lose the interest. Getting at what I'm trying to say. Please be active in the class, Abu. Uh, Please explain to me about the functioning of the pinhole camera.
What, sir?
Pinhole camera. Pinhole camera. Let me write it. Hmm. Pinhole camera. Do let me know how basically it functions. What is the principle of the functioning of a pinhole camera?
Sir, what happens is that
Hmm.
uh, when like pinhole camera has a very small hole in it,
Hmm.
so whenever we see through it, like we can see the picture inverted.
Inverted. Picture is very diminished, very small, and then it is inverted, right? So whenever you will be having a very small aperture, okay, a very small hole, that is also called as aperture. So when light is coming from an object, let's say reflected light from a plant is entering this. Let's say it is entering this, so thereby it will be forming an inverted image of this plant over here. So that is the functioning of the pinhole camera. So it is a simple camera which consists of a box that is light proof box. This is called as light proof. Why is it so? It is called as light proof because light in it cannot enter from any other source other than this hole made in it, and it is having an screen over here. There's a very thin film over which the image is obtained here. So as the light enters from this very tiny source, so thereby inverted and very diminished images form. Okay, no. Hmm. By the way, do you know who gave the principle